All right, good morning, everybody. We're going to do our weekly storage API sync where we're going to talk mainly about the relayer and the backend side of Subspace Storage Network, which Serge is leading. So, Serge, I'll turn it over to you. If you can give us an update on what you've been working on, review the code with us, and then we will talk about next steps after that.
Sure. So let me share my screen. Oh, I need to reconnect, sorry. Okay, let me share my screen. So actually very few updates this week. I've been working on continuous download of blocks to archive. So this is this PR. So previously we had this tool which downloaded blocks to our archive. It was called download substrate blocks, and it was downloading blocks from the local node, archival node, and it terminated when it processed the finalized block number. And then we had like a verification of the archive, and that's it. And after some time, our archives needed to be updated again. So in order to update our archives continuously, I have implemented another tool which we can run, which we already run as a script on our Polkadot archives droplet. So what it does, it basically does the same, but it doesn't stop. It updates, it subscribes to finalized headers on the chain and updates archives all the time. So yeah, it uses the same. So I extracted from the original script this function, fetch and store block, which accepts a block number and fetches the block, converts it to binary, to buffer, and stores it in the database. So we use this function now in two of those scripts, in the old one and the new one. And the new one also can process blocks from Genesis. For example, now we have this Genshiro parachain, which is a relatively new parachain, and we didn't have archive. But the history of the chain is, last time I was checking, was like 1.5 million blocks, and they don't have any like Docker image, so we cannot run. I mean, theoretically, we can run archival node, but it's a little bit complicated. So we used this script, and so far, I checked last time, we had already like 8 million blocks out of 15, which is not bad. So it will just take a little bit more time than processing from the local node. Yeah, any questions on this PR?
Yeah, Serge, when you say it's subscribed to finalized heads, and so we're not running a local node. So is it the same where it can subscribe to on finality and directly to the network, or is it just a single source?
If we have on finality endpoints, I'm using those because we have like API keys and they seem like more reliable in general than some endpoints of parachains. So if there is an option, we use on finality, but we can specify any like RPC endpoint.
Okay. But it's more like a single endpoint. It's not like the relayer itself where it switches between different possible endpoints.
We can use different. Yeah, we're using like same API. So we can use different, but currently we use single endpoint at least in the Docker Compose I deployed on Polkadot Archives droplet. And so far it works okay. There were no errors.
Okay, great. And how many different parachains are we archiving right now on Kusama? And I guess none on Polkadot
On
yet.
Kusama, on Polkadot, we only have Polkadot at the moment, and on Kusama, we are downloading all live parachains. So,
and what's the count on it now? Is it 14, 15?
17 maybe.
17.
Check.
Okay.
Oh, we got 18%, right?
Please don't print config on recording.
Okay.
Okay. All right. No, this is great, Serge. That's awesome. I'm glad this is just like automatic now and no more manual updating here. So this is going to make our lives a lot easier. And then with this, okay, so we've got pretty much anything that's live on Kusama that's a parachain we've got in our archives now. And then which, what could you just review for dev and test A and test B, what the sync status is of each of those with respect to these archives?
But we are using still like the old archives on test A and test B. So in order to use the recent ones, we need to copy them to the corresponding environments. So next time we restart any of the environment, we can use these new up-to-date archives.
Okay, and so none of those three environments are using these archives right now?
No.
But we don't need them. We are already synced fully, so we're just syncing from the tip of the chain.
Test A is synced fully. Test B, I'm not sure. I think we're still catching up.
And test A is public facing right now?
Yes.
Okay. Okay, cool.
And another thing, another small PR, I just updated the Polkadot dependencies because there was like a runtime update last week or beginning of this week. So there was some problems with decoding events on Polkadot relayer. So I updated this and restarted the relayer. And I also started working on validation for feeds, something we discussed yesterday with Nazar. And I was checking the parity bridges repository to refresh my knowledge of what's going on there. There are a few packages. There is a palette, Grandpa palette, and they have a module which they import in that palette that they use to verify blocks from the source chain. But they also maintain that module requires a set of known validators. So in order to verify a block, we need to provide a set of validators. And yeah, I'm just thinking, how can we maintain that set on our side at the moment? So it's still like a research stage.
Okay. How familiar are you with Grandpa consensus, like the actual protocol?
I know it's used as finalization gadget on almost all substrate-based chains, but I don't I didn't have a chance to dive into details, so probably this
Okay.
is the time.
Yeah, I think that would probably be a good start, just to make sure that you actually understand. And to be honest, I don't have a full picture. I have a very high level idea of how it works and how Finality Gadget works. Like there's some set of validators that, yeah, you absolutely need to know who the validators are. And then there's voting rules and slashing rules, and there's like a minimum amount that needs to be in agreement. Pretty sure it's 2/3 for Grandpa.
Yeah, and they
and
change according to some schedule.
yeah, there's like validator set can change, and it takes like some number of epochs for the change to go into effect. So effectively, there's a smart contract, or I mean, it's not really a smart contract because it's going to be runtime logic for us, but there's some native logic on our chain in this palette, which is going to track the validator set and be able to just check for every block, like how many votes there are, and are they from the validator set? Do they met the minimum threshold? And then as the validator set changes, that needs to get updated. And I'm certain all this is already covered in this palette or in the bridges that they have right now. It's just a matter of like extracting out the just the minimum logic that we need to do that. And it's not clear like how easy that will be, or like how modular they made this palette bridges. But that's kind of what we need you to figure out.
Yeah.
Okay.
Yeah, I guess that's all on my side.
Okay. Any other questions from our comments from the group for Serge?
Yeah, I got a question. If I want to use one of those new archive, there is no need to stop the relayer downloader. I just copy them. There is no chance to get a core block or something.
You should really
Just
stop
copy?
them, honestly.
Yeah, because
Yeah.
there is a lock on database, and I think there might be some data like corrupted if you just copy while it's downloading. Yeah, so
After copying,
it's like,
you just restore it.
yeah, it's like update archives folder, and you just run docker compose down and then copy and docker compose up, and it will catch up.
Thanks.
Okay. Any other questions? Okay, so let's do two things, Serge. Let's go through the backlog together, and if you can share your screen and go through the backlog for Relayer, and let's review some of the tasks, or see if there's any other tasks that we can bring up from there. And then I'd like to talk in just a little bit more detail about the validation of the feeds as well, to make sure that we're on the same page there.
Can you see it?
Mm-hmm.
Yeah, so this is the one I mentioned, which is currently in progress. And yeah, we haven't added anything for a long time here.
Right. Okay. And I think the no status were the ones that we had identified as the next highest priority, right?
Sorry?
The no status column, those were the ones that we had identified last time. That was sort of like the bucket of the highest priority tickets.
No, I don't think it's like it was any priority at all. Just random
Okay.
column.
Okay, well, at least that's what I thought whenever we were moving them back there, but okay, maybe not. Okay, so let's go through these. Implement source chain block size limit. So currently there is no limit on how big the block size can be. It's just the transaction size limit that we have of 3.75 megabytes.
Source chain.
I don't see why this ticket is still relevant, honestly. We can
Yeah,
support blocks up to like 3 megabytes or even more. So 1 megabyte is like arbitrary number.
Is there any more detail in the ticket?
No, I think it's It's a really old one.
Okay, so we can close that one out.
Close
Close,
or
not
delete?
delete.
Don't delete.
Okay, okay.
That just
Just leave a comment, irrelevant, and close it. We need some kind of like history for prosperity that we thought about it and we discard it and maybe why.
How do I close it? Just move to the column, or
Yeah, move to done or
oh no, it's something else. Okay.
completed. Sure, that's fine.
Okay. This one is also not relevant, I think.
yeah, it's
We-
like a more general problem. We don't have proper weights anywhere. So
Oh,
Yeah.
well, hold on. Okay, so this is separate from the cost of storage. This is the actual compute weights that we need to account
Yeah.
for. Okay. And is there anything preventing us from adding this in right now?
reproducible reference machine, for instance. Like we have many palettes and none of them have weights, so it's not unique for palette feeds.
Right.
We just have to like figure out what the reference machine is, like what we consider to be the average desktop gaming computer, let's say, and then we'll have to like run these benchmarks and then we'll figure out what the weights are.
Well, you mean the average executor machine that we want
Yes,
to use for
like
weights?
what is our reference hardware?
Yeah.
And we'll have to like order it somewhere in the cloud that we can like reproduce it. It's not like laptop that heats up, cools down, and then shows different results. So it should be like stable and reliable.
Yeah, we should also do it for the farmer as well, so we can know what the load is on them if they have to run a fraud proof. Okay.
Yeah, probably.
Okay. Has anybody done that on this call for substrate-based chains before? Done benchmarking or weights?
Yeah, I did it during Substrate Runtime Academy.
What did you use as a reference machine?
I don't think we had any reference machine.
Just run it on the laptop. Like you can do it, it will just not be super precise and it will represent your machine, not what you want.
Yeah, I think we used our own machines. And I remember after running a couple of times, I had like different results, but probably that was negligible.
Okay, so it's not like that Criterion benchmarking tool where it would like throttle your machine for a while to get it all at full speed and then run it, so you get less.
It doesn't throttle like that. It's also not reliable. Like you really need to like fix the CPU frequency and other parameters to actually get proper results. Like benchmarking on laptop is not great.
Mm-hmm. Okay.
There's too much variability.
Okay, so I guess we need to retain this, but this should move up to like a much higher level thing across all repositories. So let's just keep it in here for now. So we've got a placeholder for it. Okay. Okay. Okay,
So
backup
this was-
POV blocks. This is a good one, actually. I'm glad I'd forgotten about this. So we have a much better understanding of this now, since Nazar and Liu-Cheng and I have had to really dive deep into how Polkadot worked and Cumulus worked for the decoupled execution. So this was a request actually from Robert Habermeyer and from some of the other core devs at Polkadot. Is that do you understand what the POV block is, Serge?
Not really. I remember it's like temporary blocks. So, but I remember the main problem was that there was no API to get those.
Right. Yeah, so the way that Polkadot works, or I guess the relay chain and the parachains work, whether it's Polkadot or Kusama, is that the parachain produces a new block, and that's a state transition from an old block. And whenever they produce the new block, they produce a state transition proof, which is all the old states. Like basically, there's a bunch of transactions that change some set of accounts within the blockchain. Provide a proof that for each transaction that's changed, here's the input state, here's the output state, after running the block or all the transactions. And in most cases, this doesn't require any code because all the code is native, it's in the palette. But if you were like Moonbeam or some smart contract chain, you'd actually have to provide the internal code, like for like the smart contract that was called. And this proof is complete. So it's kind of the opposite of what we're doing in Subspace, where we say, well, we just trust that it's all correct. And then if somebody challenges it, they have to show the specific transaction or the specific transition where it was invalid. That's what the fraud proof is. They do it for everything. So they're like pessimistic, like they do it just across the board. And that's like the bulk of this POV block, but there's some additional metadata that goes in it. And then they take this block and they erasure code it, they expand it. And then this is what gets shared with the, actually I said that wrong. So it goes, the POV block goes to the what are they called? The collator sends it to the validator. The validator does the erasure coding, I believe, in Polkadot, not the collator. Is that right, Nazar?
Validators do it. Yeah.
Yeah. So the validator does the erasure coding, and that's and it wasn't clear to me actually, because I thought that they wanted the erasure coded block, but I think that they really just want the POV block. I like the original form, because we're erasure coding it already, so it doesn't really make sense to erasure code it twice. It's just the data that they care about. So I think we really just need the POV block, not the erasure coded POV block.
Yeah, they just want to distribute it across validators and not load validators with like whole POV blocks. So they just store a fraction, but due to erasure coding, they can recover it. So in our sense, it doesn't really make sense.
Yeah. So this data is only, like, these POV blocks are only retained for about 24 hours on the network. And beyond that point, there's no way to actually formally prove that some state transition occurred. And so they have, like, I don't want to say it's a problem, but it's a concern that they have that they'd like to alleviate. So they had said, well, if you guys could store not just the blocks, but these transition proofs as well, that would be really, really interesting and useful and help make Polkadot more secure. So from the API point of view, what we learned is that you can do this on the collator. Now the thing is that it's different from, like, it's not a gossip protocol here. The network protocol is different, right? So like when we think of blocks, like a node on a blockchain producing a block, we just imagine it's going to gossip it or broadcast it to all the nodes on the network. But the POV blocks don't work that way. The POV blocks, they basically a collator requests to create like a point-to-point connection to one of the validators or a subset of the validators that are actually assigned to validate that parachain for this epoch, for this number of slots. And they have to connect to them. They have to prove to them that they got elected to be a collator, to be a block producer, and then they get to send them the block. And then they might stay connected for a little while, then they'll disconnect again. But it's basically like I'm connecting to, like, you know, a handful of validators and sending them the block directly versus broadcasting it over the network. So there's not a way that we can, like, subscribe to these from the collators themselves. Like, we can't just listen to them over the network the same way that we can listen for these candidate receipts or these ParaBlocks or something like that. We can't generate them either unless we're running our own node. because the ParaBlock itself is not enough to generate the POV block. You actually have to have, you know, the state and the runtime to produce this transition proof.
POV block is actually not like a block. It's actually not even called in POV block in the code. It's just called POV. So what you are sending to validators, you are sending the regular block, and this POV, which has like inputs and outputs and all of the other stuff necessary to actually confirm that that parachain block was executed properly from start to finish. So when a validator receives it, they can take the block, they can take all the transactions, they can run through the state transition function and make sure that with the given input, the output is still matches, then it's valid. And then POV basically is thrown away because it's like verified, and the parachain block goes onto the chain.
Right. So I think the only way, so I think there's two ways we could get this out. We could either run a full node of the parachain and generate these POV blocks ourselves, which I think it's not really a hack, but we might have to like call a special command or like add an extra layer to like generate these, even if we're not elected to be the block producer, like the collator. The other way we could do it is we could try to connect into the Polkadot validator network over the network and retrieve the erasure coded POV blocks and reconstruct them after the fact. Although I'm not, I think that that's a very permission network, so I don't think that we could just.
Yeah, I don't think so.
Yeah.
Well, also the question is what we are going to do with the older blocks, which were produced like a month ago. We probably need to run a node and have like a way to retrospectively build those POVs. Because we want to have like the whole history, not just when we start archiving. And if you like, let's say, interrupt archiver for whatever reason, like for 24 hours, we'll lose some data. So we almost have to have like a modified node that can respond to queries like give me POV for this block. And in that case, we might want to probably contribute to the cumulus and just add generic RPC endpoint. That some nodes can enable, some nodes can disable if it's like performance sensitive. But would be nice to have like upstream support for this.
Yeah, that makes a lot of sense. This seems like something that Liu-Cheng would be really well suited to do with, since he's got so much experience with Cumulus already. He could probably do that very quickly. Okay, so in that case, we really do need to run full nodes of all the parachains and go back from Genesis and recreate all these POV blocks. And basically the POV block should get stored in the archives as well.
Yeah, we almost need to archive like one and the other side by side.
And I don't even actually know what the size difference is, like how big these POV or the POVs actually are. Are they the same size as block? I would imagine they could actually be much larger.
I think it depends on what particular set of transactions does, like how much state does it affect. Because basically what you include in POV, like all of the inputs that were touched by the transactions. So when you were to mimic this like runtime environment, whenever transactions do actual like read calls, they will always hit the data they need, but the general set of data is not available. So we just take the minimum set of things that contract was actually using during the execution, and we only provide that. So depending on how much stuff you read, it can be like big or small. I think it's like 5 megabytes limit, what they have. But I think it would be fair to assume that it can potentially be fairly big.
Yeah. Okay. All right, so this task is really on hold, pending two things. So one would be Liu-Cheng making some modifications to Cumulus, which we can hopefully get upstreamed, to expose these POV blocks or these POVs or generate them from a validating node and make them accessible through some RPC endpoint. The other is that it sounds like we're really migrating towards an infrastructure where we basically have a full node of every parachain running in our cloud that we can, and that's the source of the archives.
Well, if we can upstream such support, maybe on finality we'll eventually have those endpoints. Maybe they'll be like charged separately or only accessible to some people, but still be there. That would be helpful.
Yeah, we can definitely propose that to them and see what they think. That's optimistic that they would do that. Maybe they would. Even if they do, it's probably going to take a while for them to deploy it. And this is going to feed back into the motion that we're gonna propose for the Kusama Treasury and the Polkadot Treasury, is really showing like, hey, we're not just backing up the blocks and doing the archival history. We're actually helping with the security. Like we're extending the fraud proofs out from, or not fraud proofs, but the validity proofs from 24 hours to permanence, and providing a common API. There's like a whole set of things this archiving is doing. It's not just a nice to have, nice sounding thing.
It's like super archival node, basically.
Yeah. Yeah, I mean, I expect realistically we're going to have to be running like a set of droplets that are going to have these different full nodes of the parachains that are going to be connected directly into the archives in order to do this properly. But I guess, yeah, we'll definitely propose it to on finality. Okay. Okay, cool. So I guess this one's on hold for you, Serge, right now until we get some more work done, but it's on our radar again.
Should we keep it in this column or maybe in backlog?
We probably need a column of like blocked or something like that. Like,
This one.
Yeah, there we go. Okay. Is this one still relevant?
It works without proxies, but probably it will be better with.
Okay. Remind us what's the scheme right now for how it's paid for?
So now we just derive accounts and from the single one, like Alice, and yeah, we just append para ID, I think, or some identifier for the chain, and we derive a new account, a new address, and we fund all those addresses, and that's it.
Okay. And these feeds are also, there's no proof of authority or like signature check on any of these either, right? Anybody can submit data to them that pays?
Yes.
Okay. Okay.
I think it was on the roadmap to
Right.
add particular.
There is a ticket in monorepo.
Yeah.
What does that ticket specify?
To add ownership of feeds and then check ownership when you submit data.
Okay. I think that's something that we can start on now, right?
It's not fully clear how that should work. And it wasn't like high priority by any means.
Okay. Is that that ticket is in GitHub in the monorepo?
Yep.
Okay. Okay. Do we need to have that defined before we can do these proxy accounts?
I'm not sure we want proxy accounts. Yeah.
Why not? So from my understanding, from what I recall about proxy accounts, the idea was if the Kusama Treasury is going to be paying for the relay chain plus 50 parachains, that we wanted that to come from one wallet or one escrow account. That was basically, there was a $50,000 or something in DOT or KSM that went from equivalent amount of subspace credits was locked in some escrow account. Then that one account would be able to spend for all these different parachains. That was kind of the idea behind this, for all these different feeds. Sorry. And
Yeah,
that's
this
what
was the original.
Yeah, and that's what the proxy accounts is. That's the problem it's designed to solve, right?
Yeah, it's kind of more secure that we don't expose the funding account.
So does that make sense to you, Nazar?
It kind of does. I'm just not sure who exactly will run those relayers and how like this whole process will be organized. And we probably can add proxy accounts like to the blockchain itself. It's a palette, right? So we can like add it to our chain, but I think it should be up to the user, like up to the deployer of relayer, what they want to use, if they want to use it or not. So in our case, as we are running this from like test accounts, it doesn't really matter whatsoever how it actually works.
When you say up to the user, you mean the feed creator or the feed owner?
Yeah.
Yeah, definitely. I think it should be opt-in. Like we shouldn't force them to use proxy accounts, and maybe that's too complicated for most use cases. But for like a L1, L2 situation, it simplifies things. Or like one account paying for multiple feeds. Because I mean, we'll probably have the same scenario on Polkadot, probably have the same scenario on Ethereum and other like sharded blockchains. Okay, so the question is, all right, so if we have some funds that are locked in an account, then how does this fit into the relayer model, like we talked about at the offsite? So what we want to move towards is something where whoever submits the transaction, the feed put transaction that that includes the extension of the feed, that if that and this ties back into this other task of validating the feeds, like with Grandpa Consensus, like if somebody's able to produce a feed extension that with valid Grandpa Consensus, then they should be able to collect a reward from this escrow account, and anybody should be able to do that who is like staked. So there's another aspect of this, which again Liu-Cheng should probably get involved in, which is just having a basic, very basic staking mechanism here for relayers, for an election of a relayer, and then a reward for a relayer and a flashing mechanism if somebody submits an invalid extension to a feed.
This goes back to the question of whether that should be implemented as like a separate palette, hard-coded into the node or the runtime, or should it be like just a smart contract that anyone can create and customize if they want?
Yeah, I think for some of these feeds that we're doing, which are going to be like, I don't know what we want to call them, like these native feeds, perhaps. We probably do want to do it as a palette. But as other users extend, if people want to build their own custom feeds, then we want to probably make that extensible with smart contracts, not natively. But that's still further out on the roadmap till we have smart contract support in the first place. I mean, there's always going to be, as we transition to the foundation, there's always going to be some partnerships that Subspace is going to have with other blockchains, with other foundations that are going to that are basically going to be supported natively. And then there will be others.
Well, I hope not. I hope not, in a sense that we should not have those things in the runtime. Like if you look into Bitcoin, there is nothing in Bitcoin runtime that supports Ethereum or any other blockchain, right? Same about Ethereum. There is nothing in Ethereum runtime except like few hash functions that actually support anything Bitcoin related. So I'm very concerned if our runtime will support Bitcoin and Ethereum and other things, and that list will be growing, and we'll have to maintain and update all those libraries and update runtimes every time those chains change. Like that will be very messy. It would be much better if we can just have smart contracts for all of them. And whenever a new chain wants to be added, they just copy the reference smart contract. They change things if they want to update the logic and redeploy it as a smart contract for their chain specifically. So that will be more sustainable way, but I know we are quite far from that.
Yeah. Well, when Bitcoin and Ethereum were created, there was no notion of interchain interoperability. So it didn't make sense to have that kind of stuff baked in at the native level. But chains that are being created nowadays, they are actually, I mean, like in Polkadot and Kusama, the bridge is its native palette, right? For this bridging functionality. That's the way people are designing these things. Like the Ethereum bridge, like Interlay Bitcoin bridge, it's a native palette. Like, the Snow Fork.
Well, the whole point of Interlay's parachain is to integrate with Bitcoin. So it kind of makes sense. This is like the whole purpose of its existence. But we are saying that we want to connect to all of them. And then that just doesn't scale. Like even Polkadot, it only knows about like the public interface of what parachain is because it's like very, very Polkadot specific thing. Doesn't really know anything much about particular parachains, like how they actually work internally. So if you can figure out an adapter somehow that will be like super generic, sure. But if you have to like write a palette for every major chain, as we get more major chains and as they develop, it will just get very, very hard to maintain.
Yeah, I think we can definitely write interfaces and adapters for there's really like less than 10 patterns here, right? There's like proof of work, longest chain, proof of stake, longest chain. There's like Cosmos, Tendermint. There's a few like strange ones like Avalanche and Algorand, that have their own weird BFT consensus mechanism, but 90% of the chains fall under like proof of work or proof of stake, longest chain protocol. So I think we can probably have generic adapters for those, where we have like in the runtime, we have support for like the cryptographic primitives, or maybe like how to have a notion of like longest chain Nakamoto consensus. And then the remainder of that, like the config details or whatever, the validator set, tracking, all of that could be done in a smart contract. So I think it's not necessarily either or.
Yeah, if you can figure out some of those like fundamental primitives, sure.
Because it's really those like cryptographic primitives where a lot of the heavy lifting in the logic is that you get the benefit of doing it natively, or not natively, but outside the runtime, I guess. Okay. So I think regardless of that, however, we're going to have to start with it being native in the palette and then migrate that out as we add in a smart contract language. Yeah. Okay. Okay, so Serge, do you have enough information or enough knowledge of how to create these proxy accounts, like what the task is here to accomplish on this ticket, to support like basically a scenario where the Kusama, you have like one account which is paying for the relay chain plus all the parachains.
Yeah, I made an attempt to implement this, but it didn't work first time, so I need to do another one. But I think I understand the idea.
Okay, let's move that to your to-do list.
Okay.
Okay.
But grandpa validation is higher priority, right?
Yeah.
Okay.
Okay. All right. ESLint to relayer front end. So that's Leo. Okay, so everything's Leo here. Okay, Serge. There we go.
Yeah.
Yeah, I think this one is no longer relevant.
What is it? Processing new parachains history.
Yeah, it's probably when we had just Kusama and a few parachains, and I had to add more.
Okay.
So it doesn't make sense anymore.
Well, I'll try not to delete. If a task is done, let's just move it to completed. And monitoring service. That's done, isn't it?
Not really. Like we're using Datadog, but I think we should be using like Prometheus or something in the long term.
Prometheus, it's for metrics, and I think Datadog should be able to collect those metrics. So it's more like adding a library and an endpoint that library will expose with data.
So it's just about getting richer data into Datadog through Prometheus.
Well, getting some data. Like right now, it's just printing text. It's not even structured logs. The other thing will be to switch our logs from text format to JSON. So we have like date and like additional fields as parameters. So you don't have to like concatenate strings when we want to explain that this log message corresponds to, say, Kusama parachain specifically. We can have like a list of like metadata fields. So that's like a whole different thing about logging.
And
this monitoring is more about like general things. Let's say how many Kusama blocks we've archived since yesterday. That's the kind of question it can answer.
Okay. Is this something that we would run using the Prometheus embedded in the Substrate client, or do we need to set up another Prometheus process which would work directly with the relayer, the Node.js
First
app?
of all, it has nothing to do with Substrate. Second, it's basically, I was using in TypeScript library called Prom Client. It's basically a library which allows you to create these metrics and like update data. And then you can call a method that will return you a bunch of text. So you just create any HTTP server you want with any library you want, and you just expose an endpoint. And then something like Datadog will go to that endpoint like once every 30 seconds or every minute, however you want. And it will just collect that text and parse it. It's like in special format. And that's how your metrics from application get into some visualization system. Can be Grafana, can be Datadog, can be anything really.
I think I saw some library for Datadog specific, like JavaScript library. Maybe
if they support Prometheus, I
somewhere.
would recommend to use Prometheus, like a more generic solution. But yeah, it's all kind of the same. And the same thing is there is in Rust, and Substrate already uses it.
Okay. Okay, that makes more sense to me now. Let's keep that one in the backlog for now. I think we need to have a better idea of the architecture roadmap here before we implement that. Okay, put multiple.
Yeah, so I was reading that I think that Datadog supports an integration. They already got a plugin for Prometheus. It should not be hard.
Okay. Okay, put multiple. So this is what we ended up using transaction batching for instead, right?
Yeah.
And so is this no longer necessary, or is this still going to enhance on top of transaction batching?
It will like shave off maybe a few bytes per batch, but not more than that. Probably like maybe, I don't know, 4 bytes or 5 bytes per piece of data if you put a lot of things. Otherwise, batching in palette utility works pretty well. So this is something potentially useful, but it's like super low priority, I think.
Okay. So in that case, right now the focus is going to be on validation using Grandpa consensus, or validation of Grandpa consensus by trying to port over some elements from Parity Bridges Common, and then working on proxy accounts.
Yeah.
Okay, so let's talk about the optional Grandpa validation just a little bit. Kind of what, like Nazar and I talked about this some yesterday. I know he got a chance to talk to you one-on-one, but I just want to make sure we're on the same page here. So right now, Subspace is really just a dumb data store, right? It doesn't like it requires some external notion of trust or validity that we're doing to get the data in, but there's no way for the blockchain itself to know that the data is valid. Now we're planning to eventually extend this to be generic and programmable from a smart contract point of view, but it's still going to be a while till we have a smart contract framework. And there's really only one use case right now, which we can say that we can have like deterministic validity on. And that's this, are we on the longest chain of some particular feed if the feed happens to be archiving a blockchain or archiving a parachain. So from the Kusama point of view, and the Polkadot point of view, the idea is that, well, we don't actually have to verify the consensus of every individual parachain as long as we have an assumption that the validator set in Polkadot or the validator set in Kusama is honest, like honest majority assumption, or I guess 2/3 majority in their case. And as long as that's the case, then by extension, all the data that's going into Polkadot and Kusama is valid. So the idea is that if we can just validate this one Grandpa finality gadget for these chains, then Babe is also valid by extension, right? We don't need to validate the proof of stake. We just validate this finality instead. And then everything else, like the relay chain, all the parachains are valid. So then there's a question of like implementation and how does this affect kind of the current structure that we have. And there's sort of two challenges here. So one challenge is that I think I believe it's more tightly coupled right now, where all the data gets put in at once to the different feeds. And we need to make it so that we have like a two-step process. So step one is the parent feed or the source chain feed, like of the relay chain. We need to do a put call, and there should be a validation step in this put call. And only if that put call resolves true or completes, then as like a callback, then we do all the relay, all the ParaBlocks associated with that one. Okay, and right now it's all done at once, right, Serge?
Yeah.
Okay.
Well, almost.
Okay. So that's one part of this. So we need to sort of decouple and have like a two-step process here for ParaBlocks. And I think we should do this generically for any notion of like source chain and like child source chains, because it's going to be the same. I think this pattern with slight modification is going to be replicated across other blockchain networks, because like in Near, in Ethereum 2, they have the same idea where there's like a master chain where other subchains get validated and committed to. And as long as the master chain is valid, the subchains are valid as well. And even the L2s on Ethereum work under the same context, really, like Arbitrum or Optimism. Okay, so that's one part of this. Is that clear, Serge?
Yeah.
Okay. The other part is this. So what is this validation step itself? The way that we were thinking about doing this is probably to have like a runtime call, like to try to make this as like primitive and like decoupled as possible. So there would be like a runtime API call, which would basically say like, I guess there's like a contract, so to speak, or a palette in our case, where we are tracking like what is the state of the validator set, Kusama or Polkadot, and then for that state that we understand, here's a proof, like here's a grandpa proof, is it valid or not? And it should basically return like true or false, right? And if it returns true, then the put resolves complete. If it returns false, then it we don't extend the feed basically, because it's an invalid feed. It's an invalid block, right? So it shouldn't extend the feed. Like we didn't get spammed because they had to pay the transaction fee or the cost to get it in the chain in the first place. But it's just not going to actually extend the feed. So now we're making it like on-chain verifiable.
Wait, I think what's written here is not correct. We are not fetching validator set from relay chain ever.
Okay.
We need to basically interpret the blocks, right? And extract information about validator set from there.
Right.
So it should come from the chain itself, like from the data of the chain itself. And there should be some kind of current state of validator set in like runtime
In the palette
storage.
on our side.
Yeah. So like we have this current validator set we can verify against, and if it changes in the block, then we need to update it as well. But we do not need like to query some trusted third party every time we need to validate it.
Yeah, and the key thing here is we're bringing all this data in with the feed already. It's just a matter of interpreting. Like we're just treating it as opaque data right now. So we just have to interpret this data that's coming in the Kusama block header or these like special extrinsics in Kusama that actually relate to consensus, to like the change in this validator set. And this should all be handled in parity bridges common. Like they should have like, I don't know how like decoupled it is or how composable it is, but they should have the logic for all of this in there already. It's just a matter of like extracting it out or reusing it correctly.
Yeah, they do have it.
But I think the best place to start is probably just with the actual protocol, the spec, and just understanding conceptually how it works. So if we do this right, then this should be decoupled even from the notion of Kusama. It should just be like grandpa consensus, you know, validator
Substrate
set.
based chain with grandpa.
Yeah. And then whenever we do Polkadot, it should basically create another instance of this contract that just has a different validator set. You know, and that way it's like reusable and extensible. And then maybe like when we get to the smart contract level, like maybe the state of that is tracked, or like the config for that is tracked in the smart contract, and then it's just this abstract grandpa consensus, which is part of this runtime palette.
Didn't Kusama and Polkadot start with Aura early on and then transition to Babe? Was grandpa as
Yeah.
well available from the very beginning? I'm just wondering if our palette needs to be ready for this like transition as it archives blocks from Genesis.
It's a good question. And that also begs another question. Do we need to do this in the archiving process from Genesis, or are we sort of set a point in time when we actually start doing this grandpa validation with like an initial state? Because we're already running, yeah, because we're already running like an archival node in the back end to get this data in the first place. But that's a good question. Because if we have to make it backwards compatible for like all the transitions in consensus and grandpa consensus, because you know they've been upgrading grandpa itself, so that could be like a nightmare of a task in itself for full backwards compatibility from Genesis. I
Well,
think we've,
theoretically, all of the runtime logic is in the same blocks. So if our palette can extract WASM from those blocks and use that WASM to validate itself, it should kind of work and upgrade itself automatically.
theoretically.
But it will effectively run something like light client within the runtime
Yeah.
on chain.
And when we spoke with Santiago, didn't he say, who was the guy? It wasn't, was it the Pierre, the guy that does the bridges, or was that a different?
No, he was for bridging, yeah.
Yeah, I think that's what he, yeah. So
No,
when we talked to,
no, he's working on Subconnect. Sorry.
I thought they said he was also doing bridges though. I swear Santiago said
Not
like
sure.
we know somebody who, like we can put you in touch with the guy who's doing the bridges. Maybe it wasn't Pierre.
I saw lately they do something with Merkle mountain ranges. So they have like the whole palette for that, and I believe they want to do some upgrades to make it to make the whole Polkadot verifiable as on chain on Ethereum, like in a smart contract. So they're doing a lot of work to make like proofs as compact as possible and as efficient as possible. And that is probably something worth researching as well, because we might leverage that as well on our side.
Right.
Because they're really like strongly want to have bridge to Ethereum both ways. Like on Polkadot side, it's more flexible, but they need to have bridge the other way around as well.
Right.
So maybe
Okay.
the proof there would be like simpler in some way.
Yeah. Okay. Well, let's just say for now that we're only going to we're just going to start this, you know, from the last block, not from Genesis, so we can simplify it for you, Serge, in terms of what kind of validity we're actually going to support. Like what we can like initialize this this contract with like what is the current state, like in sort of a trusted way, basically, of the validator set, and then from there we can just, given this validator set, is this a valid proof? Okay. All right. Any questions on that, Serge?
No, I will do some research, and if I have, I will reach out. So far, I'm good.
Great. Okay. Anything else we need to discuss before we transition to the next call?
I think that's all, unless you have something else.
No, I'm good. All right. Well, thanks everybody. Thanks for watching. We'll see you guys on our next call. We'll be talking about Subspace JS and some of the other front end stuff.